All right, in this video, I'm going to go over adding and subtracting rational expressions. Last week I did multiplying and dividing. Why would we do multiplying and dividing first? Well, because adding and subtracting rational expressions is actually a little more difficult. Case in point, see 5 over y plus 6 over x. Some people might just go, oh, that's easy. That's just 11 over y plus x. We're done. No, 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 no. Don't do that. It's fractions, right? And what do we need in fractions? We need a common denominator. You might know it as the least common denominator, but there's some math classes where you get subtracted a point if you don't find the least common denominator in your work. But so long as you have a common denominator, that's the important thing, you will get the right answer eventually, if you remember to simplify at the end. So what is our common denominator here? Well, with variables, it's pretty easy. You just multiply it by whatever the denominator is for the other one. Over here, we're going to multiply it by x over x, right? So it'll just be y times x on the bottom. Well, that's easy. xy. Always go alphabetically when you write them out like that. So we have xy, bringing this one down here, and over 5x over xy. Now, this one will be 6y over xy, which gives us 5x plus 6y when you're adding fractions, the denominator stays the same. It's not xy plus xy, it's the 5x's in the denominations of xy. That's why we call it a denominator. It's a denomination. An example of this would be, let's say you were woodworking and you have something that's 7/8 of an inch, right? And you sand it down and you lose 1/8 of an inch. Say this is 1/2, 1/4, 3/5. Anyway, you lose 1/8 of an inch when you sand it down, make it all nice and smooth, and you end up with 6/8 of an inch, right? The denominator stays the same. It's the numerator that changes. And when we're at the end of this problem, we got to simplify because there is a simpler denomination that we could write 6/8 as. So you divide that by 2, you get 3. Divide that by 2, you get 4. So it's actually 3/4 of an inch. Same thing as 6/8 of an inch. Just a little side note, that is why the denominator stays the same when adding and subtracting fractions. And I know this all looks complicated, but that is actually the answer. We added them together. Can you factor these out? Anything out of there? No. Always check though. There's no common factor. There's no GCF there. So that's your answer. All right. First step, gotta factor. Because if you just went for least common denominator, you'd just be multiplying this whole thing times, this numerator and this denominator. And you might find that these might have some common factors, and so that you don't have to multiply quite so much by, each of these numbers to get crazy stuff. You're just going to have to simplify later anyway. So if you factor first, you can make things easier on yourself, and you'll actually find the least common denominator, which isn't necessary, but the least common denominator makes things easier for you. So what do we have? Oh, we got a perfect square and a perfect square. I like that. And what's the square root of 4 is 2. 2 times 2 is 4. So I think we've got ourselves a x plus 2 squared on our hands. And let's factor this one out. Difference of perfect squares again. Perfect square, difference there. So we get x minus 2 times x plus 2. See, they have an x plus 2 in common, but there are 2 over here. So we need another one over here to make it our common denominator. We multiply x plus 2 over x plus 2 times that. And over here, we have the 2x plus 2's, but we're missing an x minus 2. So we multiply it by x minus 2 over x minus 2. And that will give us our common denominator. So let's do this one first. We distribute that 6 over x minus 2. 6x minus 2. No, minus 12. Negative 2 times 6 is negative 12. And we're just going to leave these in factored form. Isn't that nice? We don't have to FOIL all that out. Minus, okay, so we have, wait. This is important. Got to make sure your signs are correct because we're subtracting this time. What if we think of this as a positive 2, we get 2x plus 4 on top, right? And our denominator just happens to be exactly the same. But there's that minus there. That is kind of, not kind of, it leaves this in parentheses because you're distributing a negative 1 to both. You could think of it as, well, subtraction is just adding the opposite, right? So doof, doof. I remember the doof, doof rule. 2 lines. You just pretend that negative 1 is up there and you're actually adding the opposite. Same deal. Either way, got to remember that it's negative and it changes the signs of everything in the numerator, not the denominator. The denominator is fine. So let's just rewrite it with the different signs. Negative 2x minus 4. And we're adding. Okay? Same thing. We got our common denominators. Why don't I write this answer up here? Because we got our numerator 6x minus 12 minus 2x minus 4, and the common denominator x plus 2 squared minus 2. All right. Denominator stays the same. Numerator gets combined. Now, combining like terms, we have an x term and an x term, a constant and a constant. 6 minus 2 is 4x. Negative 12 minus 4, the same as adding because it's negative minus another negative. So it's negative 16 over x plus 2 squared times x minus 2. Are we done yet? No. Still got to factor this out. We want to leave everything in factored form. So what's the GCF here? That's 4, right? We can divide by 4 here, divide by 4 here, and we'll still get an even number. So we get 4 divided by 4, or x divided by 4 is just x. Negative 16 divided by 4 is negative 4. Can we cancel anything out? I really wish that was an x minus 2. When we could cancel that out and we'd have a slightly nicer answer. But no, that is our answer. If you don't do that part, maybe minus a point on your test. Depends on your teacher. But there's your answer. All right, one more example before we call it quits on this video. This time we don't have to factor. It's already factored out. That's nice. Common denominator. Just multiply this by that and that by this. I wish there was a better way to say that. X plus 5 over x plus 5. And multiply this by x minus 3 over x minus 3. Plus 5 times x minus 3. All I did was write those next to each other. I didn't even multiply them. Just write them next to each other. 1 times x plus 5 is just x plus 5. That was the easiest math I'll do all day. All right. Now we got to combine them. Well, I can distribute this and combine them in one step if that's okay. 3 distributed. 3x minus 9. 3 times negative 3 is negative 9, yes. Minus x minus 5. Distribute that negative 1. Understood 1 there. Over x plus 5 times x minus 3. There we go. Common denominator stayed the same. We're good. Combine like terms. We got an x term and we have a constant. 3x minus 1x, understood 1 again. That would be 2x. Negative 9 minus 5. Negative 14. Really straining there. X plus 5 times x plus 3. All right, are we done? No. Not just because of that parenthesis that I just forgot, but also we can factor this. There's a GCF there. We can divide by 2. And we get x minus 7. Rewrite the 7. Over x plus 5 times x minus 3. And there's your answer. And yes, it looks like a mess. Nothing can cancel out. Don't have an x minus 7 down here. So we're good. Thanks for watching.